During the Industrial Revolution of the 1800s, something happened to the moth's natural environment. Soot turned the trees black in many areas where the pepper moth lives. Let's look at the color of pepper moths during the years after the trees started turning black. The first sample is in 1850, when the black moths were quite rare. The second sample is in 1900, 50 years later. The last sample is in 1950. The peppered moth reproduces about once each year, so this simulated experiment spans 100 generations of moths. While you watch the video, use a notebook to record the number of moths that are black and gray for each time period. Also, for each time period, record how many of each kind of moth are eaten by birds. Here is a question for you to try. Does your data show any differences between moths from 1850 and 1950? A. No, the moths were about the same. B. Yes, there were more black moths in 1850. C. Yes, there were more gray moths in 1850. Or D, I couldn't tell. Good observation. The moth population was mostly gray in 1850. Natural selection is the idea that the environment favors some variations over others. Once the trees turned dark, black moths were more likely to survive and reproduce. Over many generations, black moths went from being rare, 1 in 1,000, to being more than 90% of the population. Of course, this only happened in areas where the trees had turned black. In areas where the tree trunks were still gray, black pepper moths were still rare. Natural selection acts on variations. If there were no variations, then each individual would be identical and have an equal chance of success. The differences that help an organism survive to reproduce get passed on more often to the next generation. The opposite also happens. Variations that make an organism less likely to survive and reproduce don't get passed on to the next generation as often. These variations become less common in the population over time.